Imagine harnessing the power of magnets not just for levitation tricks, but to build a mechanical oscillator that could scale from a desktop gadget to an industrial powerhouse. This isn't sci-fi. I'm talking about MEOOPS, a magnet-only oscillator that doesn't require any external electronic drivers, just the push and pull of permanent magnets, magnetic steel, and some clever engineering. Let's break this down. Professor Lathwaite first showed us that magnetic steel can act as a coupler joining two linear magnets of equal strength and polarity. But here's the twist: if you redirect just one end's magnetic flux away from the steel using a pyrolytic barrier, suddenly, all four flux paths uncouple. The magnets go from clinging together to repelling each other, all by managing the flow of flux. Now, General Electric's classic science excursions proved magnets with the same flux strength can both push and pull objects. Think even of ultralight pyrolytic carbon. UCLA's lectures take it further. Pyrolytic carbon and bismuth actually repel both poles of a magnet, opening up a playground for controlled magnetic motion. Here's where MEOOPS comes in. Picture an octagonal device with 8 sections, each armed with 2 like-strength magnets. At the heart is a magnetic steel orb surrounded by a pyrolytic carbon bellow valve. When this valve is open, the magnets are attracted and move toward the orb. But as they approach, they close each other's valves, which blocks the magnetic flux and forces the magnets to repel, triggering them to reverse direction. It's a ballet of magnets moving, repelling, and attracting, all with no coils or switches. But why stop at motion? Every time these magnets oscillate, they're compressing piezoelectric sucrose domes and moving through copper solenoids, generating electrical voltage from both mechanical and magnetic action. Even the surface of the orb can harvest electricity via Gerdum membranes, using the triboelectric effect to capture valence electrons. All of this is encapsulated in non-repulsive Teflon tubes, so the only thing moving is the magnetic energy itself. So, what's the impact? With no moving parts to wear out, just magnets, steel, and diamagnetic barriers, MEOOPS could make self-sustaining oscillators for remote sensors, energy harvesters, or even scale up for kinetic energy storage. It's a beautiful dance of physics and engineering, using the quirks of magnetism to create something literally out of thin air. So next time you see a magnet on your fridge, remember, with the right design, those same forces could power the next generation of mechanical electrical hybrids.